Hey guys, in this video we're going to be solving this problem. Given 5 points shown on the plot below, if the initial centroids for k-means of two classes are C1 and C2, after one iteration of k-means, where will the new centroids be? Much like all the other videos, before we actually jump into solving this, I'm going to give you some background. And so for this case, we're going to cover very simply what the k-means algorithm is. So k-means is super simple. It follows four main steps. And yeah, let's just dive into it. So basically how k-means works is, let's say we have a bunch of points in space like this. As said above, k-mean follows three main steps. Oh, I don't know how to number a list. So the first step is we randomly select samples to be the centroids for our k clusters. So in this case, let's say we're doing k-means with two clusters. So we'll randomly select 2 points without replacement from our data set. So let's say this is cluster 1 centroid. So this is C1. Let's say, let's use a different color. This is C2. So let me quickly write this step out. So we randomly choose k samples. Important point right here, without replacement. To initialize our k cluster centroids. So that was a lot of words there, but that idea is pretty simple. If you read about this, we call this random initialization. There's some other approaches that we can use for k-means to initialize, but in class we learned this method. So the next step we do is what's called assignment. So in the assignment step, what we do is we now label all samples based on which cluster they're closest to. In this case, we can use the Euclidean distance. So with that in mind, well, it seems like this sample right here is closest to C1. Same thing for this sample right here. This sample right here in the middle is a little bit more confusing, so let's just assign it to C2. If there's a tie, we could randomly choose which cluster it's connected to, or we could have some sort of heuristic. In this case, let's just say that this belongs to C2, and this belongs to C3. So that's the assignment step. So the assignment step is assign all samples to cluster with nearest centroid. Pardon me if my handwriting is bad. Okay, and the third step and final step is what's called the update step. So originally when we started our algorithm, we randomly assigned samples, specific samples as our centroid to classes. In our update step, what we do is we now update the positions of our centroids based on the clusters that we have found. So in this case, we have a cluster right here. And what we'll do in the assignment step is we'll average out the positions of all the samples in the set and find a new centroid. So, visually, that new centroid would be somewhere like here, which is the kind of average X, Y position of all the samples. And then similarly, so this would now become C2, which is centroid 2, and then we would remove this centroid. And then we do the same thing for this class right here. So C1 would now move to the average of all the points, which would probably be something like here, maybe a little bit more to the left, something like here. This becomes C1, bam. So in the update step, we update position of centroids based on average position of samples in the cluster. So we did that up here, right? So our centroid moved from this position all the way down to here, just because of the average of all the samples in that cluster, and then same thing happened for C2. So I lied saying there was only 3 steps. There's actually 4 steps. Oops, let's go back here. So 4 is just repeat 2 and 3. I'm going to say forever here. It's not actually forever. In a lot of cases, you run k-means for a certain amount of iterations. So in this case, we would repeat 2 and 3 for some number of iterations. Another thing we could do is repeat this step until the centroid's position doesn't change in the update step. But yeah. Okay, so with that in mind, we can now actually answer the question. So I'm going to move this algorithm up here. And so the question is simple. We have our C1 or C2 position. So C1 is 5, 1. So this is C1 right here. It's at position Z. And then C2 is at 4, 1. It's right here. So we have to run 1 iteration of k-means. So that handles step 1 for us. We have that done. So now we have to do the assignment step. C1, and then this is C2. So in the assignment step, we need to label each sample with the centroid it's closest to, right? So obviously B and A are going to be closer to C2. Now this guy right here is kind of, it's 1 away from this guy. And in this case, it's square root of 2 away from this guy. So obviously it's closer to red. So this is also in the red cluster. Okay. So with that in mind, we've just finished the assignment steps, and now we just have to do the update step. So for black, well, we already know that, just visually, since there's only 1 sample in its class, its centroid's not going to move. So with that in mind, we can just say, well, C1 is equal to 5, 1. And that's our answer for C1, right? Because there's only 1 sample to average, so the centroid position is not going to change. However, for C2, we have 4 samples that we need to average. So we can do that up here. So the positions of these vectors are, this is y, x. I'm going to add them all up. A plus B. And this is equal to something. And I'm multiplying this by 1/4, right? Because obviously we're averaging it. Okay, so to start out, A is at 0, 0. B is at 0, 1. X is at 4, 1. And then Y is at 4, 2. So our final thing over here is 4 plus 4, that's 8. 2 plus 1 plus 1, which is 4, times 1/4. So our new centroid will now be at, I'm going to call C2 hat. So this is our new C2 position, will be at 2, 1. So if I write that out, that's right here, right? Which that means C2 now moves over here, which makes sense, right? Because it's the center of all of the samples. Okay, so C2 will be equal to 2, 1. And with that in mind, we've run one iteration of k-means. If we wanted to continue, we would repeat step 2 and 3 with the new centroids in mind, but we're only asked to do one. So thank you.